So I'm going to be talking to you about hacking CI/CD pipelines. Normally when we're talking about CI/CD pipelines in InfoSec, we're talking about things like shift-left security, how we can start implementing tooling as part of our CI/CD pipelines to find vulnerabilities earlier. This talk is not about that. This talk is about how we can exploit some of the trust relationships that exist within CI/CD systems for our own nefarious purposes. For those of you that don't know who I am, my name is Denis. I am a principal security consultant with Pulse Security. We're a local security company that do things like penetration testing, security research as a service, attacker emulation, general offensive security stuff. And I am more or less responsible for running the Auckland part of the business. I've been hacking computers professionally for over a decade now, and naturally, this talk is going to be about breaking into computers. Now, we have a lot of content to get through in a reasonably short time frame, so we're going to break it down into 3 acts. We're going to start off with sort of what CI/CD do, really, how it works from a high level. Then we're going to talk about doing some hacking, and we will wrap it up with some good old-fashioned InfoSec thought leader bullshit. Now, there's a lot of stuff that I'm going to gloss over as part of this talk. CI/CD is a complicated and involved field, so there is a lot more technical detail and specifics on the Pulse Security website here. I've written up an article that covers most of the technical content in this talk and a bunch more in depth. So if you find yourself wanting more technical information and things like that, check it out. So before we can talk about how we deploy systems now, we should probably talk about how we used to deploy systems in the past. So before there was time, and before there was anything, there were Unix admins. And part of those Unix admins' jobs was to turn up once a month, once every couple of weeks, however often deployments to production happened. They would turn up late at night, log into the jump host, log into the production servers, and they would have a list of changes. Those changes would get deployed. If there was an issue with those changes, the changes would get rolled back, and that goes back to the project. They now get to figure out what went wrong, go through the change approval board process again, and try again next month. I know this because I used to be one of these old school sysadmins back in the day. Deployment access now, though, is a little bit different. So with things like DevOps and CI/CD, we have layers of automation and abstraction that have been built on top of our base computing layer. So we have CI/CD pipelines that can deploy this stuff, means we can deploy into production more often. And this sort of sets up like how DevOps you are, kind of like how metal you are. It's like bragging rights for organizations, right? We deploy into production every 15 minutes, and that's how you know you're super, super DevOps. But underneath it all, something still has to access production. And it has to build some code, and it has to deploy it in prod. So we have layers of automation and abstraction, but the base computing sometimes is same. Now CI/CD systems look something like this. In this case, I'm looking at Octopus Deploy. Now we have 3 environments set up here in Octopus Deploy. We have dev, test, and production, and there's going to be workers, or runners, or executors, or tentacles, as they're called in the Octopus lexicon. And these are the daemons that are responsible for reading the configuration data out of the source repository or out of the CI/CD server, actually building the code, and then actually shipping it into whichever environment it needs to be shipped into. So part of this DevOps thing means that your devs are now ops, and you kind of just have to deal with it. So the flow looks something like this. If we're looking at an internet-based software as a service heavy architecture, our developers will go and merge some code into GitHub. The CI/CD system is our cloud SaaS CI/CD system. This goes and pulls those source artifacts, builds them, and then pushes them to the development environment. Okay? Now, what happens if one of those developers is compromised? So again, the CI/CD system fundamentally must have the ability to deploy systems. So if we own a developer, we can modify the pipeline configuration, extract the pipeline credentials, and now get access to whatever cloud environment it is that we want to go and get access to. And invariably, these users have very, very significant admin level privileges, so they can build up and tear down systems in whatever environment. So if the dev gets compromised, then the attacker that's compromised that dev, or a malicious dev, can pull out whatever's being used by the CI/CD system. And this is just thinking about how we can sort of mess up the configuration. What happens if one of those SaaS providers gets popped? Now, to be fair, if GitHub got owned, we would all have a very, very bad day. But what about the cloud-based CI/CD vendor? Right? What happens if they get compromised? And this is a thing that happened earlier this year for Circle CI, right? So as a security practitioner, if I'm using Circle CI to deploy all of my production AWS accounts, for example, and I found out that they've had a breach, what does that process look like for me, and how confident am I that the attacker didn't get the keys that we have exposed to Circle CI? And yes, we can have layers of KMS and Vault and abstraction that's over the top of this, but at the end of the day, that runner has to be able to reach out into that production account to do what it needs to do. And this is something that we're seeing kind of more of these days, right? Attackers are going to go and target specific individuals or specific bits of infrastructure that they deem as high value that will help them achieve their goals. Part of this, also with the software as a service side of things, is we have to deal with the shared security model. So just because something is running in the cloud or it's a product that you've paid for doesn't mean that it's implicitly secure, right? Nothing is implicitly secure. The provider of the SaaS platform has a responsibility to make sure that their infrastructure runs with a base level of security hardening and they're patching for vulnerabilities and that sort of stuff. But the configuration of that system is all you, man. And that configuration can get messed up. The SaaS provider's infrastructure can get messed up. There's a lot of ways that this can go wrong. And again, nothing is implicitly secure. So I'm going to show you what a CI/CD compromise looks like. And in this case, we're going to be attacking a default GitLab install. So this isn't a purposefully vulnerable configuration. It's just defaults, next, 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 except get it working. So I want to show you what that looks like. If I can remember how to drive Linux, maybe. Hold on. Okay. I continue to use Michael Fincham's extended mirror scripts. Right. So what I've done is I've set up a test lab that's running on my local machine, and we are going to go do some hacks. So I'm going to go to my GitLab machine, and now we have this GitLab Enterprise Edition login. Some of you may have seen how this is going to get compromised if you were in the foyer before. So I have a user, Jimbo. Jimbo is an intern that we recently hired, and maybe Jimbo's password gets compromised. Maybe Jimbo is a particularly malicious intern. Maybe we bribe Jimbo for some session cookies or something like that. In this case, Jimbo has a terrible password, and we are going to sign in as Jimbo. Now, Jimbo has access to the Super Tech project, which is part of our Summer of Tech program, but he has developer access, so this means he can't push to protected branches. There's a bunch of things that Jimbo can't do. So let's look at what else Jimbo has access to. Nothing, right? Jimbo has no access to the production repositories, anything like that. We've compromised a very, very low-value user, or a very, very low-privilege user. I'm sure Jimbo is a very valuable individual. So what I'm thinking now is, are they using CI/CD? And can I go compromise their CI/CD infrastructure in a way that'll let me get information about other things that are running on the CI/CD infra? So I'm going to create a new project, a new project repository, blank. I want to call it checkon. Now remember, we don't have a lot of permissions in dev stuff, so we are going to deploy this in Jimbo's own personal repository, because Jimbo will always have God mode in his own personal repo. So things like forcing runners to only execute protected branches, this gets around that. So let's create this project. Okay, we now have the checkon project. So scroll down, go to settings, and I'm looking for CI/CD. Runners is what I'm interested in. So these are the bits of the daemons in the servers that will actually be building the code and executing pipelines. And in this case, we have one shared runner called my Docker runner. The name of this runner already tells me some stuff that we're going to exploit shortly. So I'm going to create a malicious pipeline now, since we have access to this instance level shared runner, and we are going to do a little bit of recon. So we will go to build, and we will go to the pipeline editor. We'll configure the pipeline. Okay, sure, yes, whatever. Edit, there we go. Cool. We don't need any of this. No, sir. Okay, no, we needed some of that. We absolutely needed some of that. All right, we don't need any of that. We don't want to test or deploy. We just want one stage. We're going to call it build. We can get rid of all this nonsense. Nope, nope. Okay, now I want to figure out what's the environment look like on the runner. And I'm going to do a few things for that. I'm going to execute env. I'm going to execute, I want to see what the mounts on that server look like. And I want to take a look at the dev tree. And this will make sense in a little bit. Well, it'll probably make sense in a little bit. All right, so when we commit this change, the pipeline is automatically going to pick it up. Because there is an instance level shared runner configured, it'll automatically grab this job and execute my pipeline. We can see pipeline 10 passed. Go to my job. The job succeeded, which is fantastic. Now we can go to the raw log and dig through this a little bit. Now we want to check this out, and we want to sort of see what's going on. So we're executing on my Docker runner. We've got the GitLab runner version there, which is fine. We're using the Docker executor. This is an interesting bit of information. Now, GitLab supports multiple different executor configs. You can use Docker, you can use the Kubernetes executor, you can use the shell executor, which just executes stuff using a bash shell. In this case, we're using Docker. We scroll down, we've got echo compiling the code, and this is our environment here. So these are our environment variables that exist for our CI/CD process. Now, there's a few masked passwords. These CI variables are things that are built into GitLab as part of this CI/CD situation. This is masked, but this is just done in the front end. So if you want to get past this, just pipe env to base 64 and then decode it. In this case, I don't expect there to be any credentials in environment variables at the runner level. That's kind of unusual. I mean, it has happened in the past, so it is a good thing to check for. But in this case, we don't have anything particularly interesting in here or anything specific to this runner. In our mounts, we are indeed running Docker, which is good. Our dev mapper tells me that we are running LVM, or the file system on the underlying host, which is executing Docker. Now, what I want to figure out now is whether or not they're running Docker using Docker in Docker mode. Now, this next spiel is going to be saying the word Docker a lot. I'm sorry, but try and follow along. Okay, so if you want to build Docker containers inside your GitLab pipelines, so if you want to be able to run the Docker command and spin up containers, build them, push them off to repositories, whatever, you need to be able to execute Docker inside the runner. But the runner is inside Docker, so we have to enable Docker in Docker mode. In order to use Docker in Docker mode, we have to enable privileged mode, so we have access to the correct kernel voodoo in order to do containerization, spin up namespaces, C groups, that kind of stuff. The thing with privileged mode is, though, if you enable privileged mode, you turn off all of the sandboxing controls that containerization gives you. And there's a really easy way to figure out whether or not we're privileged. If we look at the dev tree, in this case, we can see DM0 and DM1. These are two block devices here. That's interesting. We've got access to a bunch of underlying various dev tree stuff, TTYs, and here are our raw block devices. So this is the hard disk for the underlying server that's actually executing Docker. In this situation, if we were not privileged, we wouldn't be able to see these devices at all, let alone interact with them. So the aim of the game now is to compromise this, bust out of the Docker container, and then wait for something cool to deploy and steal its environment variables and see if we can get access to stuff that we shouldn't necessarily have access to. So I'll jump back to GitLab, zoom this out a little bit. Yeah, a little bit more. Yeah, okay. Now, under code, nope, not under code. Pipeline editor. What I want to do now is I want to pop a reverse shell so I can just use this with a command line. We know it's running Docker and Docker, so here's what we're going to do. We're going to go image, name, Debian, latest. This is just so I can be comfortable with the commands that are available to me. We're going to go bash -c, and then we are going to execute bash I into and going to spit that up to dev TCP. My IP address is 192.168.200.225. This is the IP address of my attacker host here. My test lab does not have very good security architecture, so but the networking is wide open. We are running port 4321, and we want to go 0 into and 1. Hopefully I got that right. 200.225, 200.225. Okay, we'll spin up a listener, thusly. We'll make this a little bit bigger somehow. I might just restart that listener, just in case it decides to send that character. Okay, this should hopefully work now. Let's commit these changes, and now we are waiting for our connect back. And I'm sure waiting for stuff on stage is going to be fast. Yeah, cool. All right, we've got our shell. Excellent. So this is just a bash shell that's on the runner. We are running runner project 15. Project 15 is the number of Jimbo's Chicon project. Again, we run mount, see what's running here. Yeah, varlib, docker, and we've got our dev mapper VG root. So this means that it's running LVM, and normally you'd want to run LVM tools so you can get these dev mapper things set back up. Well, we don't need to do that in order to get access to the underlying block device. All we need to do is mount the correct DM device, which is DM0, and we want to mount that on MNT thusly. So what I'm doing here is I'm accessing the file system for the underlying host that's running this Docker container. Now, once you have this level of file system access, there's a bunch of different ways that you can break out of the privileged container. I'm going to do something really simple here. Just go root SSH. I'm going to cat my public key thusly. And what we want to do is we want to go echo into authorized with the Z keys. Okay. Now, if we scroll back to the top here, we can see listen, any, connect from OMGCICD, and this is going to be the IP of our server. So we can just SSH root OMGCICD. And there we go. We have now popped a root shell on the underlying host. The important thing to do now is to see how this pipeline is still running. We want to go into our reverse shell here, and we want to just exit this, because this is going to let our pipeline finish. So when you're attacking CI/CD pipelines, you have to understand that while you have this reverse shell opened, or while you're executing stuff within the pipeline, that's going to chew up an executor slot. So realistically, how we'd want to do this is we'd want to pop the container and already have an idea of what it is that we want to execute. We don't want to chew up all the CI/CD runner slots so nobody can deploy to production, and then you get busted for like ruining people's every 15 minutes into production. Now that we have access to the underlying host, I'll pop this into a different terminal so you can see it a little bit better. We can start to mess around. Let's run Docker. Okay, in this case, we have our GitLab runner right here. This is what's executing our pipelines and what's spinning up new containers. In this case, we have the GitLab server itself running on the same Docker host, and we have root on this host. At this point, if we wanted to, we could provision ourselves a new admin user, log into GitLab, steal all of the repos, steal all of the pipeline configs, steal all of the variables, and then peruse through them at a leisurely pace. This is just outstandingly poor security architecture on my part, so we're not going to do that. Instead, we're going to look at how you can exploit that GitLab runner. This becomes a waiting game now. All we do is we run PS. You can go and hook the Docker process and wait for it to spawn new containers and do it that way. And we are waiting for something else that is using that shared runner to deploy. And when that executes, we're going to do some stuff. So I'm just going to force that to happen with a curl trigger, just for the sake of time. And now, if we look at the processes, we can see some stuff is happening. And if I run docker ps, in this case, we have this new container that's deploying project 5. So that's cool. We have no access to project 5. All I want to do is docker exec this container, and I want to run env and dump the environment out to a file called env. And now I can check this out, right? So what do we got? We have a server name called prod labnet local. We have a private key, which is interesting. The user that triggered this pipeline is Imogene McDevface. And if we scroll up further, our project URL is prod stuff web. So Jimbo absolutely should not have access to prod stuff web. And now we've got this private key. So we need to get this private key into a sort of form that we can use it in, which means base64 decoding it. You can tell this is base64 by looking at it. So we'll spit this out to yoink, chmod 600 yoink, and now we want to use yoink to get access to prod.labnet.local. Cool. Now we've just got a root shell on the production server. Excellent. So the first thing we want to do is deploy our totally sweet Trojan. Whoop. Okay, Trojan deployed. Now let's see what prod is doing. So prod is this web server here where all the OMGCICD dreams come true. If we take a look, yeah, it's Nginx. Okay, so var www HTML, and now we can perform our actions on target, which is Jimbo rules. All right. There we go. We've owned production. All right. Get back to this. Slideshows. Okay. So, what just happened? What did we just do? Well, we had a CI/CD DevOps architecture that looked something like this. We have our intern that has access only to the Summer of Tech project, and we have our staff engineer, which has access to the super important production juice. Both of these things are being deployed using a shared runner. So we turned up, owned the intern, spun up a malicious project, owned the runner, and got access to production. This is effectively what happened. The underlying root cause of this problem is that we have a CI/CD runner, which is shared across trust boundaries that it should not be shared across. So we can begin some thought leadership now. So this isn't just a GitLab problem. I used GitLab here because it's easy to spin up locally inside some virtual machines, but we being Pulse Security, have done the same core steps with GitHub Actions, Octopus Deploy, Bitbucket Pipelines, GoCD, Azure DevOps, and more, right? So we very, very quickly with CI/CD run into the age-old problem of running potentially hostile workloads on the same hardware or the same infrastructure, and this is a very, very complicated issue to fix. If you would like another technical example of doing this kind of attack, Sana wrote up this advisory on using parameter injection inside Azure DevOps, and she went through and managed to kind of pop the runner and get access to the cloud God mode credentials. So again, it's not a GitLab problem, and this isn't even a GitLab vulnerability or anything like that. This is purely a CI/CD configuration and hardening issue that we've seen quite a lot in the wild. So what's the solution? Burn it all down and go back to pissed off Unix admins deploying code? Yes, that is absolutely the solution. That is 100% the solution, and it would fix this problem immediately. Unfortunately, that would be going back 2 decades, and we can't do that. So instead, we need to start looking at security controls and secure architecture. And compartmentalization comes up quite a lot when we start talking about these secure architecture practices. So if we have multiple runners, like multiple discrete bits of infrastructure that are based on trust levels, and we can lock those down to specific projects, if we structure our systems this way, then the attacker has to compromise a handful of individuals that are hopefully very well defended, and we have a limited number of people that can trigger pipelines that can get access to any kind of production credentials, right? And because we are deploying those production servers now using CI/CD, defense becomes really important, and part of that is accepting the fact that CI/CD infra and our DevOps infra and our developers, these are all critical assets now, and we have to defend them as critical assets. A compromise of our CI/CD system may very well give an attacker everything they need to hose our entire organization. So we need to start talking about things like MFA enforcement, hardening, testing, IP restrictions, that kind of stuff. There is some more galaxy brain things that you can do where if we start looking at situations where our production servers have code or deployment systems that reach out into the CI/CD system to pull the specific artifacts that they need, and then it's all deployed inside the production environment. We now have a situation where a high trust zone is reaching out into a low trust zone to go and grab specific bits of information, instead of a low trust zone having God mode access to your AWS. Just some things to think about. I don't really have any practical examples of systems that you can implement that work that way, but I'm very sure they exist. Now, when we talk about hardening these systems, though, the defaults can be dangerous, and the systems are complicated and abstract enough that writing a hardening spec or going and learning as much as you can about the system and defining some sort of hardening specification and implementing it isn't really enough anymore. The things are changing quickly, and they're complicated enough that we need to go closed loop. And what that means is we threat model, we harden, and then we test. And we see how the hardening worked. Does it work how we think it did? The more we learn about how these systems really work, we can update the threat model, because the threat model is, after all, a model, and the more technical information you can get, the more accurate you can make that model. If we run this in a loop, we can end up getting iteratively improving security over time. And these systems aren't going anywhere. So security at the cost of productivity is always going to be inevitably temporary, and I know that if AC electricity was invented today, there would be a washed-up pen tester on stage electrocuting an elephant, talking about how dangerous it is and how nobody should be using AC. And this is a really old-school InfoSec way of addressing this problem, where we're saying, don't do this, don't use cloud stuff, it's somebody else's computer, that kind of thing. And that just worked terribly for all of us, and we ended up with mad amounts of shadow IT happening. Our colleagues are clever and crafty, and if they don't agree with the security barriers that we're putting in place, they'll just go around them. They'll find a way to get around them. So the aim of the game now becomes secure enablement, rather than just saying no. Rather than just saying, no, you can go into dev and pre-prod with your CI/CD pipelines, but prod has to be done by pissed off Unix admins. They're going to get around that. They're absolutely going to get around that. So we start thinking about, how can we let people use these systems, and how can we harden them, and how can we change our environments to make sure that they can do their jobs how they see fit in a safe way. We want to treat our peers like colleagues instead of cattle. And so, look, this stuff is complicated, and the learning curve is steep, I guess. When did that disappear? Just then? Oh, man. Just been up here talking to a blank screen. There we go. Okay, but you saw this one, right? Yeah, okay, cool. We're up to date then. So, look, it's important to take a step back and think about what's really happening, okay? Underneath all of this, underneath all the DevOpses and the GitLabs and the CI/CDs and the Dockers and the privilege and the escapes and all that nonsense, underneath all of this, what was really happening is something was SSHing into a server and copying files. That's what was actually happening. And now, I'm starting to include this slide with pretty much every presentation, because it's easy to get caught up in the abstraction, the obfuscation, and especially the theatrics of cybersecurity, right? But underneath all of this, it's engineering. It's engineering, it's not magic. And the more reversing that you do, the more you understand the engineering and what's really happening on that base compute layer, the more artillery you have to be able to harden it and let your colleagues do their jobs how they see fit, while keeping them as safe as possible. So remembering what's happening underneath all the automation and all the bells and whistles, and remembering that underneath it all we have a bunch of IP tables and some SSH is really, really useful. So if I can figure this junk out, then you can absolutely figure this junk out. So I encourage you to start picking apart your systems, going and digging further into these things. And if you're part of something like a security champions program, okay, don't let them exploit your passion. Make sure you have time and make sure you get paid. Thank you.
I am a super genius.